Projectiles question, Edx M2 January 2011, question 6. Pause the video, read the question, and when you're ready, resume. So, projectiles question, but they're trying to catch you out a little bit here by putting the origin, stating that the origin is down here. So all that means is that at t is 0, the position vector isn't 0, 0. The position vector is 0, 10. 0 in the x direction and 10 in the y. And if you look at the expression they want you to show, they're asking you to show that the position vector is given by this. You'll see that agrees with what I just said. When t is 0, r is 10j. So let's just do that, and then we'll get on with the rest. So to show the position vector on the next page, then we've got, we know the acceleration is 0 minus 9.8 as usual, and we know the initial velocity vector was 3, 5. For this part, to go directly to the position vector, use the Suvat equation, s equals ut plus a half at squared, horizontally and vertically. There's no acceleration horizontally, so the x displacement is just u times t. And the initial speed horizontally is 3. So x is 3t, and y is, at first glance, you'd think y was just 5t minus 4.9t squared. But then you have to remember that as far as the position vector is concerned, relative to the origin down here, r is 3t and 10 plus 5t minus 4.9t squared. So just to convince the examiner that you know where that 10 came from, just put t equals 0, r0, the position vector at t equals 0, equals 0, 10. And that's the first bit done. Now the next bit, it says find the value of capital T. I'll just go back to the main question, the full question. And it said for 0 less than t less than capital T, the position vector is given by this. So what does capital T mean? Well, it must mean when this stops being valid, which must be when it hits the ground at here. So we've got to find the value when it hits the ground. And we also need to find an expression for the velocity as well, as it's flying through the air. So back to the page we were on. The value of t when it hits the ground, right? Remember, what we've got is a situation like this, with the projectiles going like that and hitting the ground there, and that's the origin. So y is 0. So that means 5t minus 4.9t squared plus 10 equals 0. And you've just got to solve that quadratic. So let's just rewrite it. 4.9t squared minus 5t minus 10 equals 0. Now you can use your calculator with the quadratic solving option if you've got one, or do it using the formula. When you solve that, you get t equals 2.03. And that's what they're calling capital T. 2.03. Alright, that's found the value of t for part B. For part C, you want the velocity of p at time t. You can either go back to the start of the question and do this from first principles and use v equals u plus at to write down the velocity, or the simplest way is to differentiate, because velocity is rate of change of the position vector. So v is 3 and 5 minus 9.8t, as you probably expected if you're used to these questions. And that's that bit done. So 2 more bits to do. Okay, we've got to find now the time taken for it to go to the point B when the direction of motion is 45 degrees below the horizontal. So it'll be moving like that. and that's 45 degrees. And at that point, the x component and the y component are the same. Okay. Now the expression for the of the velocity, that is, the expression for the velocity was now you have to be careful here, just stop and think. This is 3 then, and this is 5 minus 9.8t. So if it's going downwards at 45 below the horizontal, be careful to put 5 minus 9.8t is minus 3, not 3, or you'll find the time when it was going upwards at 45. That's a simple equation to solve, and that gives you t equals 0.82. That's the time. Finding the speed at that point, well, we know that it must be now 3 across 3 down, like that. So we just got to find the magnitude of v. So magnitude of v squared is 9 plus 9, which is 18, and the speed is root 18, 4.24. That's it. Let's just get the marks from the mark scheme. For part A, there was an M1 for using s equals ut plus at squared. S equals ut plus a half at squared, beg your pardon. And there was 2 accuracy marks for getting the right expression. One accuracy mark for effectively spotting that R0 was 0.10, and another one for getting the full expression. For the second part, one mark for spotting that y has to be 0, and one method mark for that, and then a method mark for getting the right, for forming the quadratic, and an accuracy mark for getting the right answer. And for the last couple of bits, 45 degrees below the horizontal, a method mark and an accuracy mark for those 2 steps there, and also a method mark and an accuracy mark for getting the speed as the magnitude of the velocity. Okay, thanks for listening. There's some information about the Further Maths support program.